How's it going, everyone? Eulia Gonzalez here again, and today we're gonna finally wrap up the concept of class and extend and now understand all of this inner finicky mechanism that is happening behind the scenes, because now this particular keyword allows us to write applications following is this approach, the object-oriented pattern. And why this is important? Because now this approach, the OOP, allows us to now write applications where the data and its relevant functionality are in the same bundle, where we can now scale applications, where we can develop solutions that are scalable. So for example, frameworks like Angular, React, Vue, Svelte, on the front end, and on the server side we have is like Express, and on top of that we can use now is Next.js as a way to solve now particularly problems, because at the end of the day, front-end frameworks, they all take about is first how you can render components, how you can have a rendering system, and then how you can now handle data on the client. Whereas on the server side, for example, like Express, okay? So how you can now interact is with the underlying OS. So how you can now build servers that are capable of is to handle large incoming requests from the users, from the browsers, with high throughput, and find ways to actually make it scalable and maintainable and easy to write and debug. So then we can look at things like Next.js, which at the end of the day, it wants to solve now specifically or several rendering modes as a ways to now be compliant with the SEO, being SEO compliance. So as you can see here, once you understand that, okay, you can now have much broad perspective about what's going on behind the scenes and what all of these frameworks, whether it's on the front end and on the back end, is offering to you. What are the solutions or the problems they're trying to solve? And that's something beautiful. That's something very, very beautiful. For example, in my case, actually, I learned all of this is by doing this reverse engineering. So by looking at, okay, now I work with Vue. Where Vue come from? Oh, it's an inspiration of React. But what is React? Oh, it's a JavaScript framework. But what is JavaScript? Oh, is this language that allows interactivity in web browsers that also now can be allow you to build server applications. And now by having one single language, you can now write front-end applications or elements, UI elements that the user is going to interact with, as well as the business logic, aka the server side. And how by doing that, we can now have a much more broad perspective of what's going on behind the scenes. So this is something that works for me. All right, I definitely would encourage people to do that. If that works for you, you will know that you will have these gut feelings. So gut feelings sometimes is something that make you do a lot of cheaty stuff. But in any case, so this course, which is taught by Will Sentence, the CEO of Codesmiths, which is this software engineering and machine learning residency headquarters in New York and California. So the idea here is for that business is to look at people that come from boot camps and then kind of accelerate that into senior roles, into roles that they can provide much more value. So in this particular course, well, we're going to see now is how this particular approach, the OOP, plays out with JavaScript to allow us to write these scalable applications in a professional engineering environment. Very, very important. And when you say professional, it is something I want to take a quick note here. So profession, according to etymology online, it stands for from the old French profession. I think I mentioned I said it right. Profession, which back then in the 12th century, it means that vows taken upon entering into a religion. And now has the idea here is not only look at the secular aspect of the word. I think secular uh, secular aspect. What the hell is this? I think it's secular. But in English, oh, exactly, secular, but not, but in a secular way, exactly. So not having a relationship, a connection with religions. Okay, so not only with the religion aspect, which is something that is behind ourselves. This is part of our nature, perhaps our psychology nature. We're not going to dive deep. I just want to mention that this, by looking at the secular aspect of this word, is that look at the commitment that you have to put, especially if you're going to dedicate your time to this. And not only in your profession, on doing one thing, but also living your life. So in any case, I think that's a very quick, interesting side note, more for a philosophical aspect, if you would like to dive into that. But now, go back here to what really matters, to the tangible world. Is that, well, in this particular course, we're going to review is the introduction to the object-oriented programming, and then how we can write objects, and how by writing objects in that particular way, in that sophisticated way, how we have some drawbacks, and how now the new keyword kicks in, thanks for the ECMAScript designers that brought that out to the language to decide, hey, we would like to automate some of these drawbacks that we have when we're creating objects with this sophisticated way, okay? Or with this way of duplicating functionality in there. Something that we're gonna recap that. And then how now this new keyword, what are the mechanisms that it's doing behind the scenes? How can we now extend our functionality with the new keywords? Okay, and how now, because of the nature of JavaScript, when you have is this keyword as well as the scope, how that actually mess you up a little bit, and how you can find a solution to actually work with the proper data. So applying a functionality with the proper data by using this arrow function, and then understand now a little bit of the way of how can we access data, okay, and how the JavaScript has some building objects that has this mechanism of inheritance, which is, I don't like to call that inheritance. In fact, they just access data, okay. This is the way of how you can tell in JavaScript, hey, I want you to access to these objects and methods. This is a reference to this. A good analogy of this is, wouldn't it be better that instead of creating, or that instead of crafting several keys, okay, anytime you lose one, okay, so you have keys under your sofa, or under your kitchens or under your fridge. You know, you have keys everywhere, right? And you know where it is, where you can find it. Wouldn't it be better that instead of having all of these duplicated keys around your house or outside of your house, which is dangerous, but in any case, wouldn't be better, all right, to have a single place where we can make sure that anytime we go there, we're gonna find our keys. Some sort of vault or some sort of hanger, right? And that's exactly the idea of the prototype change, is to, because our data is unique, okay? So if you want to, for example, identify a user, create an object user, the data is unique, okay, most of the time. But you always want to apply the same functionality regardless of the value of these objects. So because of that, well, we need to look at first how now the object prototype nature works in JavaScript. What is the default behavior that is allowing you to do that? And then now look at how you can create subclassing. This is a fancy name to say I just want is to now reuse some of my previous work, but instead of rewrite that, I want is to now reuse some of that and cover this use case. So for example, that's a good analogy, man. Yeah, that's a good analogy. If you hit the gym, okay, if you hit the gym, you have now a series of exercise that you do that for the next 3 months, 6 months, okay. There's sometimes that things become quite boring, and then you say, hey, I would like you to now that I know this, now that I know how this works, okay, I would like to now try something new. Try something new. So now that I know this, how that works, how my body responds to that, then I can now see a particular use case for doing something that is based on the foundation, but I'm trying things new. For example, the different angle in which I'm going to now perform is chest press, okay? Or what I'm gonna do is deadlift. So you already know that, and well, let's go to now do in a different angle as a way to have more activations for that. This might be a good analogy here, which is something that you are reusing your existing knowledge, but apply it to a specific use case. And I think that's something beautiful, completely. And we're gonna see how now we can do this subclassing with the object creation, okay, with this duplications or these factory functions, all right, using the sophisticated approach, and then how we can subclassing with the new and call. We can see that actually this feels like more like a hack than actually a feature from design. And then using now the new and extend and how is actually reusing this prototype nature as a way to now create objects. So first things first, we're going to focus our attention is on the practical aspect of this, and also I'm going to open up my dev tool as a way to actually write this class and how I'm going to create object, and then how I'm going to create subclass, okay, of that. In each one of this particular approach, it'll be quite interesting, quite interactive as well. And then you're gonna see that, well, this is actually what the vast majority of frameworks now is using this as a way to extend their functionality and to build frameworks that are scalable and easy to maintain. So the object-oriented programming is all about focusing on how you can now work with data and its relevant functionality in a single bundle, right? So they have this particular shape called class. But because now the language doesn't support that, recently, of course they do, but before that, they didn't do that. And this was a problem by software developers back in the 60s, where they have all of these programs with all of this data in a separate places, and they need to find a way to actually centralize. They need to find a way to actually make it easy to manage. And that is when it's, again, a quick side note here, how useful is for you, for companies, or for ourselves, as a way to now have everything in one place where we can now from then do something about it. In other words, if we know that we have everything in one place, for example, when we do our luggage, or if you have a car or you have a motorcycle, most likely when you do your luggage, okay, if you know that you have everything in one place, you know then where to find it, and you have much more control about it. And that's how now this object-oriented programming came around. So now we look at how can we create objects, again, using the object template, the notation, using the object create, and creating object with functions, and how when anytime you create an object with a function, you duplicate behaviors. So for example, this is something interesting, especially I put it on my research as a way to evaluate how you can learn and remember. And one of the things that we're doing here is apply and analyze and evaluate, something that we're going to actually see here. So one of the things here when you're creating objects, especially with a function, you say, hey, let me create here is a function called user creator, right? What I'm going to receive is the name. After all, I want this to now create an object, okay, that represents a user for a game. So this is the name and the size. Yeah, this is the name, okay, as well as the score. So far, so good. All right. So so yeah, this is the user creator. Okay. Inside of this, I'm going to now define an object here, as it is, which is the new user, like this. And how now then I can define easily is my new user properties, like name, and whatever value this parameter name from the user constructor has, I'm going to assign that to my property name under the new user. Similar to the new user here, that score is exactly score, and then here we're going to add the functionalities. For example, new user dot increment, okay, which is a function after all. That this function one is to, well, now interact with the new user here, but in this case I want to interact is with the instance, which means is that by using the this keyword, and because now that this is under the function execution context, which means is that anytime I call this function, it will run this, and that this will be the value of the left side. This is one of the rules of this. So it will mean that this is it. This is score. Okay. And then I want you to now create a new functionality called increment. I mean, it's login, right? Assign a function here and then you got is this. All right. So here I just wanted to print that a console log is with, hey, you're logging, right? Like so. Hey, you're logging. And then I want you to now create this object by saying, hey, let's go to define is the user one as a constant, and I want to call now this function called user creator with the value of Bob, not Bobo, and the score of 10, right? Then I want to say, hey, user dot increment. Want to run this function, and then I want to know is doing user one. I wanna see what is their value. If the value change, which must be is 11, increment, okay. And then on top, and then finally one is to know is call from the user one is the login methods. And you say, hey, user one is undefined. What in the F? Type error. User one is undefined. A type error here. Let me actually reload this. Okay, that's right, much better. And he tell me, hey, user one is undefined. That's interesting. In fact, I wanted to look at the score here. Exactly. And then do this. User one is undefined. That's funny. Uncap type error. User one is undefined. User creator. So this is our function. And oh, of course. Oh, of course. That's interesting. Oh, because of course I'm not returning anything. Oh, yeah. I'm not returning anything. That's what happens. Hey, return is being explicitly a language. You say, hey, yeah, but user is nothing. You're not returning anything. You're not returning as a new object. And now you say 11, and here you log in. The problem with this approach is that, as you can see, when you started to adding more and more functionality, and you're creating more and more users, you're duplicating the functionality, and that's not ideal, especially in limited environments like software. Okay, perhaps you might feel that you have a pretty good and decent budget to work with, but when it comes to now handle is scalability, the least thing that you're gonna be is being inefficient with your resource. So, because this is also a particularly interesting mindset that not only apply to software engineer, but also can be applied to your life. Okay, as a way to recognize the physical limitation that you have with your own research. Okay, and how you can put your research to be in a better position in the long run. Okay, where you can allocate your resource. Okay, so on that topic, well, the idea here is that instead of actually duplicating this, let's go to now as the key examples. Instead of having a lot of key duplicating inside of your house or outside of your house because you don't remember them, okay, you don't remember when you left that, but you remember where you put them. Well, no problem. Let's go to have a single place where we can now, anytime we go at there, we know that those functions will be there, or key will be there. And that's exactly what this particular approach is doing, okay? By saying, hey, let's go to now abstract this functionality here, okay? I'm going to abstract this functionality into its own function, into its own object, by saying, hey, this is the user functions, okay? Object, all right, like this. And let me now, in fact, let me do this. But I need to return is the object here. Return the new user. Okay. But here, let's go to define now this new user, or user functions objects. Okay. Where now I wanted to say, hey, would it be better to actually somehow, instead of creating a new object from that, we have now a reference to this object. We can have access to these objects. And the way to do that is by using the object.create. Okay? And then your objects, as it is. Object.create, what it does is to create this new object. If you take a look at the object.create here, okay, from the ambient docs, okay, object.create static methods, and when they mean static is that these are part of this built-in objects. Creates a new object using an existing object as the prototype of the newly created object. So the prototype of this newly created object will point to this existing object there. So what it's doing now is allowing us to access to those objects itself. So when now me has name and human is human property, which is something that I add here dynamically, and the other is me is human. As well, I can have access to this functionality, which is exactly what we did here by actually telling JavaScript, hey, create a new object, and then under the proto, which is what you host is the reference, this link, I want you to now make this link to be the object itself, to point to the object itself. Okay. So it had the parameters like this, the proto and the property objects. The object which should the prototype, the object which should be the prototype of the new created object. Then it's like that. So hey, I'm telling you what is the prototype that this new object, this newly created object must point or must have, and that is the user function. In other words, what is this reference here? And this is actually how you can abstract or put in one place your functionality, as well as your functionality, as well as your data into one single place. Okay, and this will work as expected. Oh, I think there is some. Okay, of course. The error is here. Let me refresh here. Yeah, by refreshing here, that we get is this, and now, voila. So for the user, nothing has changed, but for ourselves, everything has changed in terms of making our code much more readable and maintain now this particularly object-oriented programming. So, because this particular code is known as the sophisticated way of creating objects, and you must be aware of this nature, because At the end of the day, this is now how frameworks like Angular, React, Vue, Svelte, Express.js, and Next, okay, they're built on top of that as a way to now allow you as a user have access to all of this functionality. Functionalities, for example, in the case of the React, as a way to have access to this tracking mechanism, aka these hooks, all right, how you can now actually can keep track of when a state changes, when you notify that change, okay. And in the case of Vue, now you don't have to indicate that. It's just it will detect that when the value of that change, reactivity system. And in the case of Express, it's like, okay, so now how can we organize our code, okay, as a way to now handle this incoming requests and then pass through a series of transformations or a series of validations. So for example, not only validating our inputs, but also is to validate if this is the right IP with cores, if this actually is contains all the property needed, if this actually now, if this object that we're receiving as a string, can we convert that into a JSON format that now we can work on the screen or on our application. How can we now is count here with analytics, okay, as a way to say, okay, this incoming request that went through the login, for example, now I want to count that, take some analytics out there. Or if everything went wrong, I want to have a function that allow me is to send that to some error logging services, whether it's Track.js or Sentry and that kind of thing. But the idea here is the same. Is that how can we now organize all of that and make it easy for software developers to build on that and so on and so forth. So that's quite a challenge. That's quite interesting. And if you really want to solve your own problems and dive deep into this, you will end up need to know how that works. So this is how we can now create is this reference. This is known as the sophisticated approach. This is also called as the solution 2. Okay, the solution 1 was using the old approach. The solution 2 is using the object.create. And because now, anytime you create an object, you have to create this reference manually. Script designers say, hey, it'd be better to actually now, we as a JavaScript developers don't have to actually set that reference manually for us, which is there is nothing wrong with that, but let's go to automate that process. And the way to automate that process is by using the new keyword, which will change the behavior of how now you're going to create these objects. So let's get into it and how we can now transform this, okay, into what you're going to look in professional codes out there, which is, let me actually refresh this page. Wait, what? They using jQuery migrate? Well, anyway. All right. So the idea here is that instead of doing is our object function here, first let's go to define is this thing known as the function constructor, okay, where initially we're gonna do is something like this. So instead of actually now having to create this link manually for us, is the new keyword that is gonna do that behind the scenes. And the only thing that we need to do is to just use the value of this that will be point to the new object created, okay, you don't need to return anything, okay? And then you're going to update the proto reference to the prototypes of this function user creator. And you may wonder, what in the F is a prototype? Because now functions are objects, are a special type of objects, pretty much like class, which is a special type of object. But for our case, function has this combo of this shape where you can now call them, and where you can now define its property. It has this object function combo. So this object combo functions, especially the object side, is where it is known as the prototype. Is where you actually now your functionalities under this user creator. So remember that after all, the user creator is a function where you can call this, okay? But also it has another shape. It's this duality here. It has another part of this function is that it has the ability to add property to that. And the way to add those property, okay, especially functionality, is under the prototype. So that makes sense? So here you can say, okay, under the prototype of this function object combo, now I want to define is a functionality which is like this, right? Which is like this. And that's something interesting, okay? Because now, following is this particular approach, okay, the prototype dot login here, like this, without this, okay, yep, like this, okay, like this. It's like how now by this you're telling to the function object constructor, hey, the portion of the object under the prototype is where I'm going to add all of this functionality. And here now, this is what the new keyword is going to automize for us. Look at this. We've got a little less code for us, okay? If we compare that with the previous solution, like this, is a little less code. I think it's a little less code. Not sure how many lines do we have here. How can I count line here? Oh my god. Yeah, oh my god. That's a very, very interesting topic here. Okay. It has 16 lines. This approach has 16 lines. Okay. In contrast with this approach that has a little bit more lines. It's not that much. It has 39 lines. Let me actually, in fact, only count is the functionality for that. And as well as how you can create your function here. It's only 15 lines. Okay. In contrast with this, now 12 lines. So, okay. Alright. Even though the problem is that what happened is you want, for example, things okay. So what happened, for example, okay, exactly, redeclaration of that, no problem. So what happened, for example, here is a creator, functions, that kind of thing. What happened, for example, if we now want to add some more functionality into the increment, okay, like for example, well, I want to define now a function here called add, okay, that I'm going to receive is a parameter num, and I'm going to increment that to, well, to the score, this dot score, I want you to now increment, assign an increment, increment with the current value, and with this new add value. Okay, I want you to now get the current value of the score and add it with the add that we're receiving as parameter, and then assign this value to the score. All right, and then I want you to, well, for some reason, return, return this dot score. Okay, return this dot score. So okay, cool. Let me in fact reload the page. Okay, and now now that our score is that, I want to say, hey, user1 dot increment dot, which is a function, increment dot add, right? And then I want you to pass is 5, right? You say, hey, increment user1 at increment, that is not a function, which to me is that no, it is a function, but because I need to return that, that's what happened. I need to return that. All right, so that's going to return that, or in this case that's going to return, okay, is at, return that function. Or we say, hey, add this, or call add in this case. What we're gonna do is something like this. We're gonna return add. All right, we're gonna return add. So now if we do this, it'll say, hey, it still say me that user1, okay, user1 increment, all right, it's not a function. So I say, well, no problem. User1 dot increment, because it's a function, but I need to hold as a reference. Okay, where now this will is unfortunately increment that. So let's say now this. Like so. Okay. So we want now to add this another functionality to this. Okay. So, well, we say let's going to now run the increment. Okay. And then it's going to apply now. Let's define is this as an increment function. Okay. And then say, hey, increment function I want now to run is the add, okay, which is 5. So as you can see here, it say no, add function was not defined. Add is not a function. Oh, because exactly, we need to pass that as a reference. We need to pass that as a reference. Okay, we need to pass that as a reference. And then you say this. It's like, hey, increment function. I want you to return this add. What I want you to know, instead of doing that, sorry, yes, right, my bad, we haven't defined that as a an object that is going to return this function. That's what happened. So for example, like this. Okay, I want you to return this. Okay, and as you can see here, you say, okay, let me in fact doing this. So let me now add 5. For example, like this. So because now, and especially using this function, particularly like this, you want to define is nested functionality. What you want to do? Define is nested functionality. That's all. Exactly, but what happens if you want to define now nested functionality here? So for example, like this, say this is a function, okay, that I need to actually do is this. Once you're able to do this, okay, you can assign that to the increment function or the user increment function here. Alright, and then you want to try to run that user increment function, that add with the 5. Okay, it's actually returning is this, and you may wonder, what in the F is this? I don't want this. This is not what I expected. No. Well, because this function, the value of this is whatever is on the left side. And whatever is on the left side is now this function here with this string definition here is not actually the current value. This is when things started to get quite interesting, quite effed up. You know? This is when you look at this kind of thing, you say, oh, okay, what's going on? Why I don't have the proper data from that, and what you give me is this function. It's called undefined. This function. You know, what is this? Well, instead it's giving you this as a score because it doesn't it cannot find that variable, and then it's printing is the function itself, which is something that happened part of the JavaScript inner mechanism. So because the value of this is accessing is to this, okay, because we run that and we're returning that as an object. So as a way for us to access to this data, we have to do this. Okay. You may wonder, why do this is actually not something useful. We usually don't need to do this. In fact, a more particular approach is this, okay, where now the increment, instead of that you define its functionality as it is, which is much more, it makes a lot of sense. It's more professional. This is a setup you're gonna find in a lot of professional environment. What? Oh, okay, of course. is now did.score and return did.score, but it say, hey, because after all this is a function, this is an object, this is not how you have to return this. In fact, it's something like this. Okay, so now we are defining is nested functionality. Okay, nested functionality. So, well, if we define this nested functionality, which is something that we most of the time want to do as a way to encapsulate this logic here, when you try to access to that, look at this. It say, hey, user increment is not a function. So you may wonder, hey, why this is not a function? So user one dot increment dot add, and then you pass the 5, right? Quite interesting. And as you can see, it's returning now is this thing that we pass here, right? And that's interesting because, quite frankly, we don't want that. I will also argue that if you don't return the discord, so for example like this, exactly, user one is create increment is not a function. Oh, of course, it's silly me, bro. Silly me. Silly me. It say, hey, this is undefined. It's like, I don't know what is this. In fact, let me actually return this so we can actually see what's going on here. Okay, let me, in fact, is, oh Jesus. Let me is return is now this. So return this dot score. So as you can see, it's actually is returning is something called that is undefined, and then the function as it is that is wrapping that value. You know, and you may wonder, what is this? Why is returning is this function add blah 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 blah? Because remember, the value of this, which is a rule that this has, especially on function, it's a, hey, this particular rule here will be applied is when I am the function, okay, on a function definition, not a narrow definition, and I'm going, and my value will be whatever is on the left side, and whatever is on the left side is this. Is the object itself. So because of this particularly nested nature of defining functionality inside of prototype, one of the solutions that people came out with this is to actually define is the value of define something like this as a var, like that, and then you say, hey, this is, here we are now holding is a reference of the value here, and then we're gonna use that, and now this will work as expected. Okay, syntax error. Oh, because exactly we are now, okay, because we are now is exactly we're in an object, but people decide to say, well, now let me define this as a function here, where I'm going to now hold the reference of that to this, okay, and then I'll be able to run this inside of that, or define this as an object. Okay, so for example, like this. Hey, now that is this at this context, and I can have access to that as it is, right? Okay. So the thing here is that people come with things like adding is perhaps the bind to this and some sort of solution, some sort of hacky things. But the idea here is that now uh, with the arrow function, we can in fact say, hey, I would like you to pass now the proper functionality here, or by say something like this. I want you to now is the value of this will be what lexically scope, which means is that whatever is what's defined here. And now with this, we are now able is to say hey, reference at is not defined. User1 increment add. So user1 increment dot add, and then you pass this 5, but it say add is not defined. That's interesting. Add is not defined. Okay. So the problem with that approach is that, especially when you want to define is your functions here, and then you want to define some nested functionality inside of your function. Okay, so for example, like add. Okay, and then you want to say, hey, I want now you to the add run like this. By saying is this. Okay, and then I want you to return here is the add. Okay, and here you have to say, well, let me now run this function and add 5, and then let me see if you actually update the proper value score. God damn it. I'm stupid, bro. Yeah. It's like, what the fuck you think you're doing here? That's the num. Makes sense. Okay. And then when you run this function as a way to now access to the add, and then take a look at what user what user score is, which might be is 15. And let me now print that out. Console.log here. It's a hey malformant. Uncache syntax error before former parameters. I think must be is here. I think must be is here. Oh, of course. This is a function, and now you get it. Makes sense. Okay. So now with this approach, it's actually work as expected, right? Whereas with the previous approach, when we define is things like this, we say, hey, this is a function called add, and the value of this is this. Of course, you're gonna say, all right. So it actually doesn't update it, and it's pretty understandable because it's never accessing to the discourse. In fact, if you actually know what is the value of this, for example here, all right, of course we run that again. This is one of the reasons that this is a scripted language. It say this, it's not a number. It means like, I don't know what's going on here because my rule says that the value of this will be whatever is on the left side. And at this moment is increment. An increment function doesn't hold any at, or doesn't hold any score method that. So your pointing is to irrelevant data. So to fix this issue, you might say, well, now let me use the array of functions to fix that problem. One of the old ways to actually fix this problem is by saying, hey, and to this function, all right, to this function, okay, I want you to now hold the reference var here as that to this, and make use of the that as and this here. This is something that you might found. Okay, yeah, no problem. This is something that you might found in old base codes that actually work as expected. But again, because you are holding as a reference of the relevant data, and then you're going to pass down there. We're not going to dive deep actually into how this actually. This is more like a hack. But the point of this is by looking at how now this work, okay, with the new keyword, and how we can come up with a solution, especially with the this and its scope. Then you can now think in terms of, all right, so what is doing now the class behind the scene is say, this is a function constructor, okay, and this is the methods, and also the functionality that is inside of this, okay, in the increment, in the logging. So the class, after all, what it's doing is just adding some syntactical sugar of what's going on behind this. And that's interesting, because at the end of the day, the thing here is that by looking at how this actually works, you can now understand that when you're using class and extend, which is something that we're going to explain that later, is that what it's doing is using this inherit or this property or this prototype nature here, where we don't actually now have to do this for ourselves. It is doing that for us to look like more a class, to look like or to have this facade, to write code like look like class object-oriented programming, but behind the scene is using the prototype inheritance. So before going into the class and extend, we need to look at how can we make subclassing. And again, we're gonna make it very, very quickly here to see how can we now do this subclassing with factory functions. Okay, so I'm not going to create that by the scratch, especially the functions. This is how we can create our functions using the object.create. Okay, and then as a way to define is how can we now set the reference of our subclass to reuse previous work. So for example, by saying let me define a new pay user creator function, okay, that it'll take now is the name and the score, which is property that is going to use our base class, as well as the balance. Okay, so by now understanding this, and you say, all right, because after all we're gonna use because after all we're gonna look at the sophisticated way of how you can access data. Okay, and that is, well, we say let's go to create a new user. Okay, this is our new pay user. By running the function there of the user creator, where we're gonna pass is the name and the scores, and we're gonna receive is this new object that has a reference to their base method. In other words, is the user function. And then we're gonna use this the object built-in property called set property of, which is quite confusing because after all, you might think that you are actually modifying is the prototype or set the prototype, but in reality what you're setting is the reference, which is the dunder proto render that actually guarantees this prototype change. It's a way of how you can access property from another object until it reaches to the pointer null, until there is no more elements that you can now access properties or methods. So here we say, let me now overwrite the new pay user here, a new pay user reference, okay, and then point to this new functionality that we haven't created right now. But we can do this by saying, hey, pay user functions, okay, which is now an object, okay, that will contain is our custom use cases functions or custom functions. So here we got is the say increment balance, right? You say, hey, this will be a function that now is going to take a look at this value where we're going to call these objects, in their balance property, which is something that we're going to create, is going to increment that. So now here we're saying, hey, forget your own proto reference to that base functionality and points to this to the new one, okay, points to the new one here, which is the paid user function, paid user functions, okay, and from there you're gonna say, okay, now let's going to actually add the property from that balance, and we're gonna return is our object, right? Remember, we're in the sophisticated approach, and as a way to now make the link to the base class, we're gonna use the object dot set prototype, but now from this object where it holds all of our variables, which is pay user functions. So your proto, I want you to now point to the base class, and that is the user functions. So now this, when I construct this object by saying, hey, let's go to now construct this user paid one by running now this function called user, or I mean is paid user creator, and I'm gonna pass here the alias, and the score, which is 5, and their balance, which is 18, right? And then I want to now run the user paid, or pay user, sorry, I should have put that in way. User pay one is paid user, my bad. Anyway, pay user one, to say, hey, I want you to now call is this functions like the increment balance. All right, I want to know what my balance is by saying, okay, this is the balance, user pay one dot increment, but in this case I want to know my balance. And then I want you now to run functions user paid that are in the, for example, the login, in the base class, like the login. There's an error here with the missing uncaught syntax error. It's a after dot missing name after missing name. Wait, what? We're returning as a new pay user. Exactly. Missing. Oh my god. Oh my freaking god. Okay. Yeah. As usual, human errors is the console log, and now you get this, right? As you can see, it's actually work as expected. So this is how you can create now subclassing by modifying and mutating by modifying and mutating is the proto reference from this object, okay? As a way to say, okay, now let me access to this property and method from this base class. So far, so good. No problem at all, okay? So now with the new keyword, okay, we're gonna see how we can create well, our own classes here. So for our demo purpose, we're gonna do is this. We're gonna paste is the base class using the new keyword. You defining is the function constructor, and then the prototype and the functionality inside of the prototype. Okay, so far so good. Nothing has changed. But now let's go to cover this particular use case. Use case like, for example, once you already know how to do a particular exercise when you hit the gym for 3 or 6, 9 months, now you say, okay, it is time to now it is time to now it is time to I'll see how can we now access to this property and methods. Okay, so let's get into it. So the way of how can we now do that is by defining, similar when we hit the gym. You say, okay, now that I know all of these exercise that I have done over the past 9 months, okay, now I want to look at things that are much more interesting, okay, to cover some use cases, to do something special here, to do something different. Okay, good, that's fine. Yep. Okay, good, that's fine. So pretty much that's exactly what we're gonna do with the this new object, which is, well, let's going to define as our function constructor, but for the paid user creator, okay, that will receive some parameters like the name from the base class, name, Alice, name, score, and balance. Okay, let me put it here as this function. But because now we're gonna work with the new keywords, like how can we create our reference? After all, this reference is being created by ourselves. We don't have too much control of what's going on. It's only the new keyword that actually doing this. So how can we do that? This is one of the most finicky aspects here on JavaScript. When you say, okay, because we cannot access, because we cannot have control of how this is going to work, because we cannot have access to, because we can control which reference we're going to link to. This is on the new keyword. Well, an alternative here is that when we create these objects, because at the end of the day, the new keyword, it first look at this value, which is something that it has in any function execution context. Look at this value, set it to empty. This is when you're going to add all of the property and methods, and then automate the process of linking the proto reference from this newly object created, this new instance under this value, and points that to the prototype of this function creator, of this, and point to the prototype of the function constructor. In this case, the page user creator. And knowing that, it's like, okay, holy F, after all you are modifying is the value of this, so we need to find a way to actually get the value of this updated, and then you do your magic, and then you actually update that. So this is when you take now the base class, like the user creator, okay, and say, okay, let me now run this function, okay, without the new keyword, because after all, what we're gonna do is to use one of the special functions called call, part of the built-in functions that we have now as in JavaScript under the prototype, or more, this is part of the instance as a call here. It's also important to actually understand that terminology as a way to understand these the MDN docs. Is that, hey, this internal methods, aka methods, so these internal methods are now available for this object that is called apply and bind. So binds allow you to set the value of this inside of this context, okay, and at definition time, whereas the call and apply allow you to do that at runtime. The subtle difference is that the way how you pass parameters, comma separated value with call and apply as an array-like style. Okay, so with the user creator name.score here, we're now going to call this function that is not going to return is a new object. In fact, what it's going to do is to set this value here. So here we're doing is, hey, this value from this pay user creator context, I want you to pass down, update that. It means create all of that at the base class and then pass me down as a side effect. Jesus. Pass me that as a side effect. What now here I'm going to create is the balance, or we're going to add all of this property, and then now this newly object created will have a reference to the pay user creator prototype, and the function constructor prototype, which is the pay user creator. So this dot balance here will be the balance, okay, and because now when we're going to define our functionality is under the prototype, when it's under the prototype of this newly object creator, we're going to now update to the base class by saying user creator dot prototype, and then you define your functionality here inside of that function constructor, user creator dot prototype, so such as the increment balance. All right, and then you have now is, well, this is the pay user creator prototype, the increment balance. This is when you say, okay, define your function. Your function pretty much as it is, right? Pretty much. Okay. And here you say, hey, this dot balance plus plus. So now when it times to create actually our object, for example, I paid user, and now this time I did this, I wrote it well. It's gonna use a new keyword as a way to say, hey, the new or the paid user creator. Okay, what I'm going to pass is now the name of Bob, and 5 as a score, and 18 as a balance. And then I say, okay, I want you to now run the increment balance functionality, and also at the same time I want you to now, well, show me what is the balance right now, paid user dot balance, as well as to see if we're actually getting is the inheritance by calling is this login methods. So by looking at the lookup process of the login, JavaScript say, hey, do we have these login functions inside of our function creator? And they pay user creator, which is the when you call this, it has name, score, and this balance. No, we don't have them. But we don't panic. Let me take a look now at the proto that has a reference. Okay, let me look at the prototype of these functions to see if I have them, and that is increment balance. No, don't panic. Now let me take a look at the proto reference, dunder proto dunder, that has a reference here to the user creator. Okay, where now here I have is the increment. No, that's not what I want. I have the login. Yes, then run this. It's a redeclaration of all of this. No problem. Reload. Beep, beep, beep. And user creator is undefined. User creator. Oh, because it's user creator. User creator. On the pay user creator, the prototype will be is the user creator function dot prototype. Oh, I think it's when it's calling here, the user creator is undefined. Exactly, this is the function, and under the function you have is now prototype increment. That's right, as well as the login here, and you create your new user without any issue. And then you have is this pay user creator. We call this the user creator here. Name, score. Then you call this. All right. And then the user creator prototype, like this. This is when you now update that reference and then add some more property to that. Okay, I don't think. What about now? But it says on the pay user create. Oh my god, what? Uncaught type error. User creator is undefined. Oh, because this is not the way. Because this is not the way how you pass this. Because in fact, you do is like this, and then is when you pass is the other parameter. Exactly. And now, okay, it's telling you, oh, this is interesting. It's a user creator is undefined. Exactly, because here user creator, we're gonna call that, and the way to call that is by actually from the function object constructor we call that, and then it will work. As you can see, 19, hey, you're logging, and that's it. So this is the way of how you can now do subclassing here. Jesus. This is now how you can do subclassing here when building these applications, okay, that actually scale to serve multiple purpose and that kind of thing. All right, my God. All right, my God. So now finally is to take a look at the last segment of all of this, which is, let's go to transform now this into a class-based type, which is, well, pretty straightforward. You can define as a class, okay, called user creator. And what you're gonna do behind the scenes is to first, the anatomy of this is that you must have a constructor function that is going to receive is your parameter, name and score here, and then you're going to assign all of this name to that, which are actually referencing to the proper, so the value of this is actually referencing to this instance, which means that to the relevant data. So this dot score is equal to the score here, and now that you define your function constructor, it is time to define your functionalities, where in our case is increment. Okay, you say this is the way how you can define your methods. Increment, where here you say, hey, I want you to access to the value of this reference or this instance, and then the score, well, I want not to increase it. Similar for the login. This is another method that I define here, where now here I want you to now console log this stuff as it is, right? Say this yeah, there you go. Constructor, increment, and login. So here you say, hey, you're logging. And when it comes to construct that, which is creating this new object, you say, hey, this will be the user one, new user creator with Alice and 10, and now behind the scenes the new keyword, it'll do a couple things for you. You know, the new keyword here is actually so the new keyword here is also setting up the value of this as an empty object, which is great. Okay, so the value of this is setting up as a new object, which is great. Set the proto to points that. Set the proto to points to the prototype. Here is actually doing the same thing when you're creating your base class. Okay, when you're creating your base class, generating is that this value, so it's running as a function construction, where it's going to actually now set the value of this as an empty object, and then assign all of the property that you do to that this value. Set now the proto reference that points to the prototype property of this function object class, because after all, class is a special type of function objects. And inside of the prototype is when it is the increment and login and all of these methods that you define that. So this is the reason why you can, when running this, you can now print that without any issues. Actually, this is a much more cleaner way, but behind the scenes we are using is the prototype inheritance. So JavaScript designers look at this and say, hey, this is actually nasty. We shouldn't do this. We are ashamed of the prototype nature. So we would like that our language looks like more like classical object-oriented programming, like Python and Ruby. And well, we need to reuse this prototype nature, but we want our code to be readable. That's the entire point of this. Readable by following this approach. So we're not reinventing the wheel. So because of that, now that we have this new way of creating object, when it comes to actually now creating subclassing, this is when things started to get interesting, my friend. Very, 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 very interesting. Oh yeah, they will. Oh yeah, they will. Yeah, they will.
Refers to let's go run.
Which is something that we're gonna focus in today's video. Because now this is what it's doing behind the scenes.
Just like we did before. Go run user creator. Here we go. So super refers to let's go run user creator. Just like we did before. Go run user creator. Here we go. So super refers to let's go run user creator. Just like we did before. Here we go. So super. Here we go. Here we go. So. Are you ready for this? I'm ready for this. This is our final code, folks. Paid user 1 is actually getting dark. This is a very bad sign. Okay. This is our final code. We're like down to our final code. This is our final execution concept we're going to do tonight. Sorry. Let's pretend today. Alright. Paid user 1. Let's pretend for ourselves. Called with that mutative, that powerful new keyword, call paid user creator, pass in, emitter, 8 and 25. Okay, here we go. Big execution context. There it is. Into it we go. And the first thing, the first thing in local memory are our argument parameter commas. Let's have Michael help us out with those. The calling pages creator, that means we run the pages creator function, which happens to now be called constructor as part of a class, but it is just a function here. And that says we're accepting paid name base or account balance. So talk me through the parameter argument matching here. Beautiful.
The paid name will be that.
25. Okay. And that, what am I clicking on? And now we're calling the new keyword. Nick, this is your specialty area. What does this get us doing? Oh, I can't help you out. It's not your specialty area this time because now in a class it does do something weird. So there is a this assignment, but it is uninitialized. Nothing there. Okay.
Let me take a look now at classes. So classes. Character class. Nope. Oh my god. It's 2 classes. Classes. And how you can, no, this is definition, which is, there's nothing wrong with that. Exactly. Those static means that they are defining is on the class, not on the instance. So they can be now used as utility functions for configurations or catching to create utility functions for an application, whereas static fields are useful for catch and fixed configuration. Mm-hmm. Mm-hmm. Exactly, evaluation. Okay. When a class declaration or class expression is evaluated, it is various components are evaluating. Okay, let me now, in fact, is take a look at the class, but from the ECMA script, from the spec. Yep. Let me take a look from the spec here. Class definition here. Okay, but how this is actually evaluation here. Runtime semantic evaluation. Class definition. Perform binding class declaration evaluation of this class declaration. Run empty. Run binding class declaration evaluation. Class elements evaluation. The syntax direct operation binding class declaration evaluation takes no arguments and returns either normal completion containing a function object or an abrupt completion. Exactly. Takes no arguments and return either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions: class declaration, class binding identifier, class tail. Let class name be a string value or binding identifier. Let value be class definition. Let the environment be the running execution context. Because after all, it's a function. Perform initialize bound name. And then you get is this. So let class be the string value of binding identifiers. Let value be class definition evaluation. Let value be class definition evaluation of class tail with argument class name and class name. Set value dot sort text to the sort text matches by class declaration. Let environment be running execution context. So it create a new execution context. Let environment be the new execution, be the running execution context. Lexical environment. Perform initialize bound name this. So define, and then set, and define, and then act upon that. So you return the value. Class declaration. This is binding class declaration evaluation. and this is the evaluation. Perform by the class declaration evaluation of this class declaration and return empty. Okay. So when a class declaration or class expression is evaluated, its various components are evaluated in the following order. Okay. Its various components are evaluated in the following order. The extend clause, if present, it is first evaluated. Okay, which is something that we're gonna do. Subclassing. Hey, this is first evaluated. It must evaluate to a valid constructor, function, or null, or a type error is thrown. Interesting. So we're gonna take a look at the extend, and I'm gonna say, hey, I'm going to evaluate if there is a valid constructor function. The constructor method is extracted, substituted with the default implementation. The constructor method is extracted, substituted with the default implementation. If constructor is not present. Okay, if this is not present, the constructor method is extracted. However, because the constructor definition is only a method definition, this step is not observable. Because the constructor definition is only a method definition, this step is not observable. The class elements property keys are evaluated in order of declaration. If the property key is computed, the computed expression is evaluated. So question, yeah, oh my god, no, what the fuck? So question is that if I create a new class, for example, class or an object here called test 101, and here you say, hey, this will be the private method without any constructor, okay, without any constructor function. Exactly, it's a special method for creating and initializing an object, creating with a class. So, but this is to initialize, exactly, to initialize, but this is a special object to initialize that. For creating a new instance and initialize. For creation and initialization. So for example, if you say something like test one with the, or let's say box, Jesus, box with size here, size 10, okay, and methods like get size. You define this as, well, let me now do this dot get, this dot size, So return size. You can also, in fact, okay. Oh yeah, but you define is this like a private method? I mean, you can create a new instance here. We say const new box. Say class box here by saying new box. Say new box. You can have access to the size, which is like an static method, okay, which belongs to the class, not the instance. Which is a part of the class, not part of the instance. You can say get size from that. But the thing is that you cannot make it dynamic here. You cannot make this box dynamic. And that's the reason why we have this kind of thing. Okay. That's the reason why we have a constructor. To initialize, to create and initialize as an object. Makes a lot of sense. Okay. Makes a lot of sense. Okay. Exactly. This is how you can define public class field. All right. Okay.
And we immediately must.
So, looking now at this, class body, constructor, initialize methods, that kind of thing, and the evaluation order. So the extend clause is present if evaluated first, and it must evaluate to a valid constructor function or null, exactly to a valid constructor function or null. The constructor method is extracted, substituted with the default implementation if construction is not present. However, because a constructor definition is only a method definition, this step is not observable. The class element's property keys are evaluated in the order of declaration. If the property key is computed, the computed expression is evaluated with the this value set to the this value, surrounding to the class, not the class itself. None of the property values are evaluated. Methods and accessors are installed in the order of declaration. So this is the class element. So the class element property keys are evaluated in the order of declaration. If the property key is computed, the computed expression is evaluated. Exactly. But is that if the property key is computed, as it is, exactly. If the property key is computed, the computed expression is evaluated with the this value set to the this value. So if the class is like, I know you want to be very detailed about it. Make it simple, bro. Make it simple. Make it simple. So the class element properties keys are evaluated in the order of declaration. The class element properties. You think you're funny? a class element can be characterized, okay, by kind, location, and visibility. Getter setters are methods, okay. Getter setters are methods, static or instance, public or private. So the class elements, getter setters, and methods, okay. So the class elements can be characterized in three aspects: the kind, getter setters, methods, or fields. Okay, getter setters, methods or fields. You have these visual representations. You need to have this visual representation to make sense of this shit. Okay, locations, whether it's a static or okay, where it's going to be on the instance or on the static or on this class. And visibility, oh my god, they will be public or okay. So they can be labeled, these class elements can be labeled or be characterized by three aspects. So their kind, which is a getter or a setter or a method or a property or a field, okay, method or a field, all right. It can be for kind, getter, setter, field, or methods, or it can be for locations, static, exactly, static or instance, or it can be for visibility, or public or private. Okay, this is the anatomy of this class elements. It's characterized. So the class elements property keys are evaluated in the order of declaration. Okay, how you define that? They are being evaluated. If the property key is computed, the computed expression is evaluated. With this value, the computed expression. What in the F mean computed expression? If the property key is computed, what do you mean by computed? Okay, if the property key is computed, okay, if the property key is computed, the computed expression is evaluated. Okay, the computed expression is evaluated with the this value set to the this value set to the this value. In other words, it's initializing here with the this, and then it's going to now append each one of them. Method and accessors are installed in the order of declarations. Instance methods and accessors are installed on the prototype property. Methods and accessors. Okay, methods and accessors. Methods and accessors. Methods and accessors. Okay, methods and accessors are installed in the order of declaration. Instance methods are accessors are installed on the prototype. Okay, so the okay. So I'm going to now add these instance methods and accessors under the prototype property of the current class. And a static method and accessor are installed on the class itself. Private instance method and accessor are safe to be installed on the instance directly later. This step is not observable. The class is now initialized with the prototype specified by the extents and implementation. The class is now initialized with the prototype specified by extents and implementations specified by the constructor. For all the step above, If an evaluated expression tries to access the name of the class, a reference error is thrown because the class is not initialized. The class element's values are evaluated in the order of the declaration. Instance fields in static and static invalidation. The class is now fully initialized and can be used as a constructor function. This page introduces the constructor syntax for the constructor property present in all objects. See object prototype construction. Present in all objects. A class method called constructor cannot be a getter, setter, async, or generator. A class has not more than one constructor method because this is used by initializing and creating the new instance. A constructor enables you to provide any custom initialization that must be done before any other method can be called on an instantiated object. Okay, using a new class, go through the following step. If it is derived class, the constructor body before the super call is evaluated. This part should not access this because it's not yet initialized. So initially, it's not initialized. It's defined but not initialized. If it is a derived class, okay, if it is a derived class, the super call is evaluated. The constructor body before the super call is evaluated. This part should not access this because it's not yet initialized. If it is a derived class, the super class calls evaluated, which initialize the parent class through the same process. The current class fields are initialized. The constructor body after the super call of the entire body, if it's a base class, is evaluated. Within the constructor body, you can access the object being created through this. Exactly, you can have access to the object being created through this and access the class that is called with new. And access the class that is called with new through new.target. Know that methods including getters and setters and the prototype chains are already initialized on the diffs before the constructor is executed. So you can even access methods of a subclass from the constructor of the superclass. However, if those methods use this, the this will have not been fully initialized yet. This means reading public fields of the derived class will result in undefined. Object undefined, exactly. Computer properties. The object initializing syntax also support computer property names. Okay, computer properties. They call this computer property object initializers. Object initializers. Object initializers. Object initializers. Object initializers. Computer property. The object initializer syntax also support computer property names that allow you to put an expression in square brackets. Computer property cannot become construction. Okay, because now it's calling that constructor from the base class, and then you can have access to this. Okay. Calling super in a constructor bound to a different property. New instance is still an instance of the polygon. However, because super called rectangle as a constructor, The name property of a new instance is initialized with the logic in rectangle. However, because super calls rectangle as a constructor, the name, however, because super is calls rectangle as a constructor, the name property of a new instance is initialized with the logic in rectangle. What the fuck? Using new on the class, go through the following step. The current class fields are initialized. The constructor body after the super calls of the entire body, if it is a base class, is evaluated. But in other words, is that if it is a derived class, the constructor body before the super call is evaluated. This part should not access to this because it's not yet initialized. If it is a derived class, the super call is evaluated, which initializes the parent class through the same process. So it initializes the value of this as new. Oh my god. This is the constructor. Any constructor that can be called with new and has the prototype property can be candidate for the parent class. The two conditions must be whole. For example, bound functions and proxy can be constructed, but they don't have prototype property, so they cannot be subclasses. Okay, no, okay. Chill, bro. chill, bro. Go.
Have a super cool before we want to refer to that bit. It is there, it's uninitialized, but we cannot refer to it. It's not undefined. We're going to console log above the super, which is hopefully going to go call the user creator to create down my object. We are not going to run user creator and have it have a side effect on the this we create with the new keyword here. No, this fundamentally changes the class structure, how and where our pertinent object, the one we're creating, that will eventually be called in page 1, is actually being called. It is not being called in page creator. It is actually going to be born in user creator. And that is a design decision of the JavaScript team to make it be born in page creator. Sorry. To make it be born in user creator constructor.
The base class.
It is born in there. And then it is automatically returned out and assigned to the this out here. Versus, remember in the previous version, we had side effects on the object we created here. Okay, so let's start doing this. So we're going to call, so it's unassigned right now, uninitialized right now. We call super with what arguments, Chris? Which is, which have what values?
Alyssa and 8.
And they're going to go into, as what parameter argument on those in the constructor? Name is going to be Alyssa, so it's going to be inside the execution context. Okay. Create the execution context. I'm actually going to do this. This equals, I don't want to say pseudo equals, you can't assign to this, behind the scenes what's happening. This is going to equal the return value of calling super. Now, I'm going to actually show you briefly what actually happens. It does this. There's a new thing in JavaScript that allows you to call a constructor function, that's a function that should have a new keyword in front of it, that allows you to do it without the new keyword. It's called like reflect.construct. Because someone typed that into Google. I think Mark, do you mind typing reflect.construct? It's EWN. Reflect.construct. I'm actually going to show you what this exactly does behind the scenes. I'm going to do it in red because it really is about the extent that makes this happen. Okay? So it's going to be reflect. Does it say reflect.construct exists? Yeah. Reflect.construct. Okay? Its first argument is the function that's going to be creating the object. What is the function going to create the object? It is user creator because it goes to look for proto and it's user creator. This is just what it's doing behind the scenes. User creator, and then the arguments. Alyssa, I promised myself not to do this bit, but there we go. And then the function whose prototype object we want to have the returned object that comes out of the call to super point to, which is paid user creator. So paid user creator, paid user creator. But for our purposes, and then that returns out an object into this. But for our purposes, just think of it as the super. We can write it a couple of ways. Think of it as the super being. Super goes, oh no, what do I want to run to produce the object? Well, the object I want to have is the user object, but we're going to add a bunch of stuff to it. So go run the user creator constructor. How do we know to run that? Because extends put in the proto a reference to the user creator function. The user creator constructor function. So super goes, no, what's super?
Extends put, exactly, because extend put a reference on the proto folder. Okay, it's because extend put a reference under the proto to the base class function constructor.
Like this. But in the local memory, super is set to user creator. Not literally, we normally think of it as super is set to user creator. Okay. So super is set to user creator, called with Alyssa, and 8, and that's going to be stored in this. These are the 3 different ways of saying the same thing. Don't worry too much about this reflect.construct thing. It's just a new way of allowing us to, and behind the scenes, is really what's happening. We're running user creator with, the new keyword in front of it. It's going to return out the object we know well and love, but we're going to control the returned out object proto to not be to user creator prototype object, but instead to be to pay user creator prototype object. Okay, let's just do it. That's not what I regret bringing that reflect.construct thing, but just know that what we passed in last there means that this running a super user creator is going to set the prototype to be paid user creator prototype, not user creator prototype.
What is the extent that actually is doing that?
Here we go. So super refers to let's go run user creator. Just like we did before. Go run user creator. We are now able to generate an object that does not have function on it and use it, and the point is made up. Proto to the user creator function object. To user creator. Just send down here.
Exactly, they can be candidate for the parent class.
Okay. Let's send that down slightly.
If the condition must be both hold true.
Proto, the
prototype property of the parent class.
Anything that the function has access to will be. This is the moment we go,
The prototype property of the parent class must be an object
is that when we run paid user creator,
or null.
it's going to create an
But
object
you will
side,
rarely
we're gonna
worry
call
about this
super,
practice because a non-object prototype doesn't behave as it should anyway. It is ignored by the new keyword.
create an object. From the context there. I'm going to dive into this piece.
I want to extend that just a little bit. So if you left off constructor on page creator, it's going to look in proto for constructor and just run constructor directly.
That's a different factor. We leave off constructor.
Extend set the
it's gonna
prototype for
automatically
both
simple constructor.
the child
Look at
and
what
child class
equals
prototype.
subclass, not a base class, but a subclass. Look at what it has on it. That was just from, and everything in red was added by extends. One portion ensures the objects come out of running this function.
Extends set the prototype for both child class
The other portion, the other consequence of extends,
and child class
ensures the
prototype.
super, which when we run page user creator, we're going to run, makes us go and run user creator to make the object there. And that is stored, that link is stored in the proto. That is where it's stored. If you overwrite proto,
Extend set the prototype for both child class, which is the function constructor, and the child class prototype.
and the child class prototype. That is where it's stored. If you overwrite proto, extends set the prototype for both child class, which is the function constructor, and the child class prototype.
Extend set the prototype for both child class, which is the function constructor, and the child class prototype.
then the super goes, I'm not there anymore. When you call super inside of that, because it is absolutely any program I'm going to look up here. If you overwrite this with
Okay, so that'll be all for this video. Take care. Bye bye.